Building the world for a game is a lot of tedious work, so I decided to use some procedural generation tricks such as Cellular Automata and wait tables to help me handcraft the world for my game. Howdy, and welcome to Game Endeavor, where I post devlogs for my game Zoe and the Cursed Dreamer. I'm developing a game where you'll be able to run around an overworld to discover caves and dungeons, fight monsters, and obtain loot. Creating the world that you'll explore is going to be one of my greatest tasks because it'll need to be interesting so that it holds your attention and be fun to explore. I've decided to hand build this world as opposed to procedurally generating it because I feel like generated worlds are rarely as fun to play in and aren't nearly as memorable. But at the same time, hand placing every blade of grass or trying to build a natural cave system can be an exhaustive and time-consuming process. Full disclosure, I am a very lazy developer. I don't enjoy repetitive tasks that I can force a computer to do for me. So of course, it wasn't long until I started automating a lot of my development workload. The only reason I've waited this long to do it is because I wanted to implement these features in the recently added level editor. However, it's not as though I could just click a button and automate the process for automating the development. I had to dedicate valuable time for creating these tools and actually implement the logic behind them, which means I needed to learn some procedural generation. When I'm placing grass decorations in the world, I'll be placing each cluster of grass, but I'll be automating the process for shaping these clusters, determining which tile variation to use, how often to use flowers, and even flipping the tile horizontally for even more variation. To create these clusters for the grass decorations, I'm using a method of procedural generation known as Cellular Automata. If you're not aware of what this is, then the best way I can describe it is that it's a grid of cells that are either true or false. You start out with a configuration of these cells, such as a randomized with a percentage chance for each cell to be true, and then you iterate through each of these cells and change its value based on the set of rules. If you simulate this rule set enough times, then you'll start generating various shapes and patterns based on whatever the rule set you've used. The parameter for these rule sets can be very finicky though, and give you wildly different values with even minor changes. We discovered this the hard way while experimenting with these values in the live stream earlier this week. I expect I'll be using Cellular Automata frequently to create random shapes, so I went and created a resource class that can generate these with a few method calls. However, the thing about Cellular Automata is that there's not one way to define a rule set. I need to be able to tell the automata how to apply my rule set without having to define it inside of the resource class. To do this, I took inspiration from Godot's arrays, which have a custom sort method that allow you to pass in a class and a method name that will be used to sort the array. I did this by passing in the value that has the method, and a string with the value of the method that I want to call. And then, inside of the automata script, I used gdscript's call method to call this method and pass in the current value of the cell and how many neighbors it has. I'm also using Cellular Automata to generate cave-like structures that will be used in the game. The reason I'm doing this is because handcrafting cave-like structures that are natural and convincing is a very difficult and mentally exhausting. Again, you need to be random and avoid creating shapes that are too uniform, which is something that I'm not very good at. So I've been working on a script that will generate cave-like structures to act as a starting point for the caves in my game. This is used to give me some ideas for the layout of a cave and how the player might progress through it. I've even created a little pop-up dialog menu that will give me a preview of the cave system before it gets placed in the world. This is useful because the caves that I'm generating are often hit and miss whether or not I like them. So this way I can randomize the layout several times until I find one that I like, and I don't have to invest a whole lot of time ensuring that an interesting cave is generated each and every time. These features are nice, but because they're random, it can be a lot of trial and error when placing them in the world. Remove it if I don't like it and then try again. So to help me when placing these features, I wanted to create an undo feature to remove anything that I don't like, and I also wanted to create a preview for placing things in the world. Adding this undo feature has actually taken me down an interesting little rabbit hole that I've allowed myself to follow simply out of curiosity. I'm a very curious developer that enjoys learning new things and expanding my skill set and knowledge, even though it quite often leads me on these little tangents that distract me from the task that I set out to accomplish. This can even make it difficult to write scripts for these devlogs because it's almost like rubber ducking the logic for my game. I'll realize that I can do something differently or get an idea that I start writing the code for, and the next thing I know it's 11 PM at night and I only have 2 minutes worth of script, but a useless feature that's fun to play with. The issue with the undo is that I need to know whenever any tile set in my level editor is about to change. With that knowledge, I can store the previous state of the tile to be reapplied whenever I perform an undo. Godot's tile map doesn't emit signals when it's about to change or after having done so, which can make this a bit cumbersome to work around. However, Godot is open source, which means that you can download the source off of GitHub, make whatever modifications you want, compile it, and the engine will have your changes applied to it. So I set out to add my own tile change signal to the tile maps by compiling Godot Engine with my custom signals added to it. Adding your own signal to the engine is surprisingly easy. You just need to add the signal that you want with the arguments that it will emit, and then you can call an emit signal function and pass in those values, just like you would within GDScript. As for handling the undo feature itself, the level editor listens for any changes to the tile map that are applied by the user. It will then append the current information about the tile before it changes in a multi-dimensional array. When the user does something such as release a mouse after having drawn a bit of dirt texture, it will then push a new array onto the undo history. And then when I want to undo, I simply pop off the second array from the stack and set the tiles back how they were, iterating backwards through the array. With the undo feature implemented, I still wanted to be able to see my changes before I applied them, however. This way I could perform a few randomizations until I found the shape that I liked, and then apply it however I wanted. This meant that I needed to add a preview feature into my level editor. The trick with this is getting the preview to match up with whatever I'm trying to place, because I also want to use this for several different things like tile maps and entities and ground textures, enemies, and more. I decided to handle this by adding a new tile map over whatever tile set that I'm wanting to preview. I then transfer the information from the tile map that I'm mimicking, but I unset the collision layers and math just to be safe, and then I lower the alpha for the tile map. Whenever the user moves the mouse and changes the cell that they're currently hovering over, I clear the preview and reapply it over the new cell that the mouse is hovering over. And I also added the ability to right-click the mouse when the grass generator tool is selected. It will generate a new grass layout, which is then updated in the preview. When building areas in the level editor, I have a zoomed out view of the world and I can more easily place tiles with my fancy custom brushes. But building the world this way makes it difficult to get a proper sense of scale. This is important because I could easily make a stretch of road that is too long or boring for a player to navigate, and not realize this until it's too late because I've connected it to something else or wasted a lot of time decorating it. So to help me test the world as I'm building it, I added in the ability to hot swap between the level editor and playing the game. With the press of a button, I can then cause the player to spawn at a specific location in the game, which allows me to test features such as enemy encounters, looting chests, or just seeing how fun an area is to explore. As for the overworld itself, it will ideally be seamless for the most part, which means that it's going to be one large scene that the player can explore with a few loading screens. However, I am going to need different scenes for interiors like caves and dungeons, and even a debug area where I could test game mechanics without altering the actual game scenes. So I needed to add another feature into my level editor that will allow me to create, save, and load separate scenes. As you may have noticed, my level editor is starting to look like an actual application, which is an interesting thing about Godot. It actually has enough UI features in it that you can build proper applications, as many have before, such as the sleek looking Pixelorama project, or RPG in a box. So I added in a file menu with some map related options, and if you select a new map, then you'll be presented with a pop-up menu that allows you to name the map. This name is then used to set the identity and file name of the map, which is then read in by the loader when you choose to open a previously saved map. This is also where I'm currently placing some of the generative tools, such as the cave generation and any other tools that I decided to create later. We hooked this up in our last stream, so making new generators is as simple as extending the editor generator script and using the generate method that it gets called to manipulate the level data. A big thank you to all the patrons that have supported these videos. If you want to see what else I've been working on, then there's a playlist in the corner that will get you started. And if you're new, then join the sub club and ding-a-ling that bell to get notified for future videos.